Hey guys, in this example we're asked to compute the area of the shaded region here. It looks like a portion of the circle that's cut off by chord AB, and we're given some information about the chord. So the chord is formed by a central angle of 90 degrees, right, and then 90-degree central angle, and the side lengths here are each 12 inches as the radius of the circle, and so this forms an isosceles right triangle here, right? So let's do a couple things. Let's first start by, the way we're going to approach this is we are first going to start by computing the area of the whole entire shape. Okay, that's supposed to, I'm trying to match the color to make that, so that we're going to compute the area of the entire sector. It's supposed to be a right angle there, right? So the entire sector. And then what are we going to do? Well, then we're going to go back and subtract out the area of the triangle, right? So the triangle itself. So minus this, and then this will be our answer, right? So that's a very beautiful picture of what we're going to try to do. All right, so let's start with the area of the sector of the circle. So the sector's area is equal to, remember, it's equal to 1/2 times r squared times theta, where this theta is in radians actually, which we haven't really talked too much about radians, so this is just how I remember this formula. But what we need to do then is convert this into, this is given to us in degrees, we're working in degrees, right? So this is then 1/2 r squared times theta in degrees times pi over 180. Okay, so over 180, and altogether this gives us the formula from the book, which is that it's the angle measure, theta, times r squared times pi, all divided by 360. And so this will be our answer to the area of the sector. We're going to leave the pi in here. I'm going to get an exact answer for this problem. So I'm not going to use a calculator. I'm going to work this out and get an exact answer. And so now at this point, what do we need to do? Well, we need to plug in the r. The r is the radius of the circle. So the r is this 12, right? So r is 12. And we need to plug in the angle. The angle, of course, is a 90-degree angle. So our angle is 90. And because of the degrees, actually we don't have to worry about the degree units here. I've always told us that we have to be very careful of degrees. If we're going to be careful, we need to be careful always, right? And add the degrees to the bottom as well. But they're going to cancel, so let's not worry about it. So the area is going to equal then 90 times 12 squared times pi over 360. All right, that's the area of the sector. Remember, that's like the slice of pizza. That's called a sector. To compute this, I'm going to need some help, right? So this actually cancels. 9 goes into 36 4 times, and the zeros cancel. So this ends up being, if we kind of write this as 12 times 12, and then write this as 2 times 2, right? Times pi, just 4 is 2 times 2, 12 squared means 12 times 12. And then from each of these, we do this little trick where we cancel a 2, so that we still have a perfect square, but now it's 6 squared, right? And so this ends up telling us then that the area of the sector is 36 pi. And even if you're using a calculator, you leave pi at this point. You do not approximate pi by anything yet, right? Only at the very end do you write down an approximation. All right, the next thing we need to do is look at this triangle. So this triangle is an isosceles triangle. It's an isosceles right triangle, but the fact that it's a right triangle is very useful, right? So let's look at the triangle. Triangles, we know their area is equal to 1/2 base times height, and the fact that it's a right triangle means that the base and the height are the legs, right? The legs are exactly the base and the height. So this one's going to be 1/2 times 12 squared, right? Base times height. Base and height are each 12. And so what do we get here? Well, we can do kind of a similar trick, but not exactly. So what do we get here then? This is going to be 1/2 times 144. That's 12 squared. And half of 144 is 72. Right? So 72 is the area of the triangle. And remember that pi is bigger than 3, right? So 36, notice, is half of 72. So this is this is bigger than 72 because it's 3 times 36, which is bigger than 2 times 36. So the area of the sector number, the number that we got, is larger than the number for the triangle, and just based on the picture, it had to be that way. So it's good to think through and make sure that that's right. And then our final answer is just to subtract these two, right? And so the final area, this is the area enclosed by that chord. So this is the original question, right? The part that was shaded in the picture before I started drawing on it. The final area is just going to be 36 pi, take away the 72 units from the triangle, and I'm going to leave it just like that. So there's an exact answer, 36 pi minus 72, and this is in whatever units that we had squared, right? Square units for, oh, it's inches, so we should write exactly what it is. So this is in square inches, okay? So always add the units when you're given the units. We were given units on this one, so we add in that inches squared as part of our final answer.